Welcome to Statics Lectures by Civil Thinking, and today we are going to solve a problem on truss analysis using method of joints. Now before I move on, I suggest you to please watch the video lectures on truss analysis one by one in sequence as in the playlist so that you understand better. The playlist link is in the description, or also you can click on the pop-up on your screen. Now in today's class we will see how to find the member forces or the forces in each member of this truss using method of joints. Okay, now this is a truss with a pin support at A and a roll support at D. Okay, now these are the correct answers, and when we solve the problem we will tally our answers with this and see if we get the correct answer. Okay, now so to begin with the method of joints, we have some steps. Basically I can put them in multiple steps, but I like to put it only in two steps. So the first step is draw FBD. FBD means free body diagram of this truss and find the support reactions. Okay, now we in the first step, first of all we have to draw a free body diagram. Okay, now how do we get a free body diagram of the whole truss? We simply replace these supports with the support reactions. Okay, now this is a pin support, and at a pin we know there are two reactions. Okay, so if I erase this pin support and I replace it with its reactions like this, now we have two reactions at a pin support. Okay, now the vertical axis is the y-axis and the horizontal axis is x-axis. Okay, so this reaction I will call it as AY, means reaction, support reaction at A in the y direction, and this horizontal reaction at A I will call this as AX, reaction at A in the x direction. Okay, and please note I have assumed the AY reaction to be upwards and AX reaction is towards right. Okay, this is just an assumption. When we find the support reactions, if we get a positive value means our assumed directions were correct, and if we get a negative value, that means our assumed directions were wrong, and the actual direction of these support reactions is opposite to what we assume. Okay, so now here we have a roller support, so to replace it with a support reaction, there is only one support reaction in case of a roller. Okay, so let me erase this. At a roller there is only one reaction, and it is vertical reaction. Okay, dy. Okay, now this is the free body diagram. Okay, FBD. Okay, FBD of this whole truss is simply when we replace these supports in terms of the reactions. Okay, when we replace the supports with their respective support reactions, then we get the free body diagram or the FBD of the whole truss. Okay, now we have to find the support reactions. Now how do we find the support reactions? We find the support reactions using by applying the equations of equilibrium. Okay, equations of equilibrium, right? We find the support reactions using equations of equilibrium. And what are those equations of equilibrium? They are basically three for a two-dimensional object. Summation of force about x-axis is 0, summation of force about y-axis is 0, and summation of moment at any point of this truss is 0. Now these three we call them as equations of equilibrium. By the way, I have already made a video lecture on equations of equilibrium. You can watch it if you want, if you want more clarification. Now let us apply these equations one by one. Let's first apply, let me apply this equation first. Okay, because this way we save time. Okay, always apply moment equation first. If you want to save time, you can apply basically any of these equations, but I have found that if you apply this equation first, it saves our time. Okay, now summation of moment about any point is 0. Let me choose the point to be point D, this point. Okay, now I am assuming clockwise movements are positive and anti-clockwise movements are negative. Okay, now AY is going to exert a clockwise movement at D, so the moment due to AY at D is positive. Okay, so I will write it like this: AY multiplied by how far is AY from D? We have to find the normal distance, right? So it is 4 plus 4 is 8, 8 plus 4 is 12, right? So multiplied by 12 meter. Now AX is passing through point D, so the moment of AX about D will be 0. Okay, now this 6 kilonewton, it is going to exert an anti-clockwise movement at D, so the moment due to 6 kilonewton is going to be negative, so I will write negative here. 6 kilonewton multiplied by how far is 6 kilonewton normally from point D? It is 4 plus 4, right? The distance between 6 kilonewton, the normal distance between 6 kilonewton and point D is 4 plus 4, right? So it is 8 meters. Now again, this 9 kilonewton is going to exert an anti-clockwise movement at D. So again, it is going to be negative 9 kilonewton. What is the normal distance between 9 kilonewton and D? It is 4 multiplied by 4 meters. Okay, so now the moment due to dy at point D is going to be 0 because it's passing through D, right? So this becomes our equation of this equation, right? Summation of moment at D is 0, we get this. Okay, now from here you see the only unknown is AY, right? So I guess we can find the value of AY from here. So let me rearrange this equation first. So when we put these terms to the right of equal sign, so we'll get positive, right? So this was negative, so it is going to be equal. It is going to be positive. Sorry, yes. Now this was negative term, so it is going to be positive when we throw this equation to the right side of equal sign. Now 8 6 is 48, right? It is 48. Now this is kilonewton meter, right? Kilonewton meter. Kilonewton meter plus 9 4 is 36. Again it is kilonewton meter, right? Kilonewton meter. Okay, now this is 12 meter multiplied by AY, right? Now from here I will get the value of AY to be what? Now I have to rearrange it again. 12 meter, I will throw it to the right side of equal sign, so it is going to be in the denominator, right? So this is going to be the value of AY. Okay, so let me use a calculator to find the value. It is 48 plus 36 divided by 12. It is 7. Now let us talk about units. Now this is kilonewton meter, this is kilonewton meter, so the numerator is in kilonewton meter. Okay, and the denominator is in meter, so meter and meter will cancel out, right? So we are left with kilonewton. Okay, so 7 kilonewton is the support reaction AY. Okay, so this is 7 kilonewton. Since we get a positive value, right? 7 kilonewton, it is a positive value. It means the support reaction at A is actually upwards. Okay, if we had get, for example, -7, then we would do what? We would just, it is upward, assume it is upwards, then we would put it in the downward. Okay, but right now we get a positive value, so it means our assumed direction is right. So we have a 7 kilonewton reaction at support A upwards. Okay, it is 7 kilonewton meter, 7 kilonewton upwards. Okay, now we will apply this equation. Okay, summation f of y equals 0. Now first let me erase all of this first. Okay, so this is 7 kilonewton. Now let us apply this equation. Okay, summation of fy equals 0. What does it mean? Summation means sum of, f means forces, y means in the y direction. So this means sum of all the forces in the y direction. Now which is y direction? Y direction is the vertical direction. Okay, we have to sum up all the forces in the vertical direction. These are all vertical forces. Okay, and we have to equate it to 0, and I am assuming the upward forces are positive. Okay, so let's apply. Now 7 kilonewton is upwards, so it is positive. Now 6 kilonewton is also a vertical force, right? Now AX is not a vertical force, so we will not include AX in this equation. So yeah, 6 kilonewton is downward, so this one is negative, right? Because upwards are positive, so the downwards are negative. Minus 6 kilonewton. Again 9 is downwards, so this is also negative. Now dy is upwards. I have assumed dy to be upwards. Okay, so it is positive. So these are all the forces in the y direction or the vertical direction, and we have to equate it to 0. Okay, now from here we will get the value of dy. Okay, so from here what is going to be the value of dy? If I throw all these terms to the right side of equal sign, so it is going to be, now 7, it is going to be negative, this 9 is going to be positive 9. Okay, then this is going to be positive 6, right? And this is going to be negative 7, right? Remember, everything is in kilonewton, right? So this is 9 plus 6 minus 7, so we get a value of 8. Okay, 8 what? 8 kilonewton. Okay, since we get a positive value, so it means our assumed dy direction is actually upwards. Okay, so this is, we get 8 kilonewton, right? Now let me apply this equation, summation of f of x. Summation of f of x equal to 0. It means sum of all the forces in the x is the horizontal direction. We have to sum up all the forces in the horizontal direction and equate it to what? Equate it to 0. Okay, now let us see how many forces do we have in horizontal direction. Now I can see only ax is the only force which is in the horizontal direction. Okay, so we get here ax. Okay, do we have another force in the horizontal? No, so we equate it to 0. Okay, so the support reaction, this ax is 0. Okay, since it is 0, we will not write 0 here. Okay, we will not write like this, because it is 0, it means it does not exist, so we'll simply erase it. Okay, so our first step is complete. We have drawn the free body diagram and we also find the support reactions. Okay, now let's come to the step 2. Okay, so let me erase all of these things first. Okay, now apply method of joints to each joint one by one. We apply method of joints to one joint, then we go to another joint, then we go to another joint. Okay, this way we will get the forces in each member. Okay, when we apply method of joints at this joint A, we will get member forces in all the members connected to A. Okay, now which members are connected to A? Now this AB is connected to A, so we will get the member force in AB when we apply method of joints at joint A. We will also get the value of AE when we apply method of joints at A, right? Similarly, when we apply method of joints at D, what we get? We will get member force in CD and ED, right? Because CD and ED are connected at D. Similarly, when we apply method of joints at this, we will get member forces in all the members connected to this joint. Okay, so first, now the rule is basically, to begin with a joint which is relatively simple, which have less unknowns. Okay, or which is easy to analyze. Okay, now what do we mean by apply method of joints? When we say apply method of joints, we apply equations of equilibrium at the joint, at that point. Okay, when we apply method of joints at joint A, we actually or basically apply equations of equilibrium at joint A. Okay, now because this is a point, right? Joint is a point, and for a point there are only two equations of equilibrium, right? Summation of force in the y direction is 0 and summation of force in the x direction is 0. Okay, so let's begin one by one. So let us first begin at joint A. Okay, let us say this is joint A. Okay, Now we have this upward of 7 kilonewton, okay, and then we have one force will be in this, right, AE. So I'm assuming the member force, the force in AE member is tensile, okay. We all always assume tensile, okay, tensile force, and then when we get a negative value, it means our assumption was wrong and the force was actually compressive force, okay. So this arrow, it is away from the joint, it means tensile, okay. Now if an arrow is towards the joint, it means compressed, okay, because we are assuming this AE force is tensile, so we will denote it with FAE. We will denote it with an arrow outwards, okay, away from the joint. FAE means force in AE member, okay. Now we also have AB connected to AE, right? Okay, so we will also represent it with an arrow, tensile arrow, outward arrow, and this is force in AB, okay. And we have some angle here, theta, okay. Now before applying the equations of equilibrium at this joint A, right, now let's first find the angle theta, okay, this theta angle. And I think when we apply the method of joints at joint B, we also need this angle, okay, theta. Let us call this angle as what, alpha, okay. Now because this truss is symmetric, it is, this angle is also going to be theta, and this angle is also going to be alpha, okay. Now let's first find this theta angle, okay. Now how we are going to do that, you see, we will draw a line, normal line here, okay. Now from A to this normal line is AB plus up to this, right. Let me show it here. We draw a normal line at E, okay. Now from here to here it is half of 4, right. This is 2 meter. I couldn't show it correctly, I'm sorry for that. It is basically, you know, this normal is bisecting this BC into two equal parts, okay. Like, I don't know if excuse my handwriting. So this is 2 meter and this is 2 meter, right. So total distance from A, right, let me show it here. From, this is 7 kilonewton, I will write it here. From this to this point it is 4 plus 2, right. 4 plus 2 is 6 meter, all right. And what is the vertical distance from here to here? It is 6 meters, right. So this is 6 meters. So if we look at this in triangle A, let me call this as you know, B dash. Now when you look at this right angle triangle A B dash E, right, this right angle triangle, this triangle, okay. How we are going to find theta? Now in this right angle triangle, the vertical distance, or the, you know, the perpendicular component and the base component is given, so we will apply tan theta, okay. Now in this triangle tan theta is going to be 6 meters divided by, this vertical is 6 and divided by total is 6, right, divided by 6 meters, okay. So 6 by 6 is 1, so theta is tan inverse of 1, right, and tan inverse of 1 is 45 degrees, okay. So this theta is 45 degrees, okay. Now let us also find alpha, okay. Now this alpha is, let us, you know, we'll analyze this triangle B B dash E, right, in right angle triangle B B dash E, uh, alpha is tan inverse of, now the vertical is 6 meters divided by, the base of this triangle is 2 meters, right, BB dash is 2 meters, so it is 2 meters, right. So this is tan inverse of what, 6 divided by 2 is 3, right, tan inverse of 3, right. Now let me apply, use the calculator. Tan inverse of 3, it is 71.56, right, so which is approximately equal to 71.56 6, 71.6 approximately. Okay, so this alpha, I will write it here, 71.6 degrees. Okay, so now we found these angles, so let's apply the method of joints at A. Okay, before that let me erase all of this. Now this is the x-axis, right? This is the x-axis and we have this y-axis. Okay, this is y-axis, right? Now FAE, it is inclined force, so this FA is inclined force. Okay, and when we apply summation of force in the x direction, what we do basically, we add up all the forces in the x direction, right? And when we apply summation of f of y equal to 0, what does that mean? That means we sum up all the forces in y direction, right? Now look at this FAE. This FAE is neither in the x direction nor in the y direction, right? So when we apply these equations, we will not be able to fit FAE in these two equations, right? Because summation f of x means for sum of all the forces in x direction. Now is FAE in x direction? No, so we can't fit it in x direction. Also, summation of forces in the y direction is 0, means we have to sum up all the forces in y direction. As we can see, in y direction is 7, right? But FAE is not in y, so we are not able to fit FAE in any of these two equations. So in order to make this fit in these two equations, what we are going to do, we are going to resolve this force into two components. Okay, one is the x component and another is the y component. Okay, then we will apply these equations and we will consider these components. Okay, instead of this. Okay, instead of the actual force, we will consider these components in the equation. Okay, because these components are in the x direction and y direction, so yes, we can include them. Because we include the components of this force, it means we have included it, right? So now this angle is theta, so this component, the x component, is going to be FAE cosine of theta, right? And this component is going to be FAE multiplied by the sine function of theta, right? Sine theta. Okay, so let us first apply this equation. Summation of force about y equal to 0. Why? Because always first apply that equation where we have a known. Okay, we have a known value. Now when you look at this, you have this 7 kilonewton. It is a known value, right? And this known value is in vertical direction. Vertical direction is y direction. So since we have a known value in the y direction, so first we apply this equation. Okay, so I'm again assuming upward forces are positive and the downward forces are negative. Now this 7 is upward, so it is 7 kilonewton. Now FAE sine theta is also assumed to be upward, so this is also positive. FAE sine theta. Remember, we know the value of theta. It is 45 degrees, right? Theta is 45 degrees. Do we have another force in the y direction? No. So summation of all these forces, we have to equate it to 0. Okay. Now from here we are going to get the value of FAE. Okay, to be minus 7 kilonewton divided by sine 45 degrees. Okay, so let me use the calculator to find the value. Minus 7 divided by sine of 45 degrees. Okay, so the value is negative 7 square root of 2, which is approximately equal to negative 9.9. Okay, of course it is in kilonewton. Okay, so force in AE is negative, means what? Now this force in AE, we have assumed this. Now this was joint and this arrow is away from the joint. Now the away from joint means what? It means tensile force. We assumed FAE to be tensile, but basically our assumption was wrong. It is actually what? It is actually compressive. Okay, it is like this. Okay, it is like this towards the joint. Okay, we'll see about that later on. Okay, don't worry about that. Now negative 9.9 means 9.9 kilonewton, but compressive, C for compressive. Okay, so force in AE, where is the answer? Yes, this is the answer. Force in AE is 9.9 kilonewton compressive. Okay, so our calculations are right. Okay, now let us apply this. We applied this equation, right? Summation f of y. Now let us apply this summation f of x equal to 0. Okay, for that I will write the value of FAE here. It is negative 9.9 kilonewton. Okay, because we will need this. So let me erase this first. Okay, now let's apply this equation. Summation of force in the x direction is 0. We are going to apply this equation at joint A. I'm assuming forces to the right, they are positive, and forces to the left are negative. Okay, so now look at the x-axis. Now this FAB is in x-axis, it is towards right, so it is positive. Now we have another force in x direction, which is FA cosine of theta. It is also towards right, it is going to be positive. Cosine of theta, remember theta is 45 degrees. Do we have another force in x direction? No, so it is equal to 0. Now FA is negative 9.9. okay, now first of all FAB is going to be what? When we find the value of FAB from here, okay, it is going to be negative FAE cosine of 45, right? Now FA is negative 9.9. okay, so negative and negative will cancel out, so all of it is going to be positive 9.9 kilonewton multiplied by cosine of 45. Okay, so when I use the calculator, 9.9 cosine of 45, what is the value? It is exactly 7 kilonewton. Okay, 7 kilonewton. Okay, now it is a positive value. The positive value means what? It means our assumption was right. And what is the assumption? FAB is positive, right? Now FAB is positive, it means it is away from the joint, which means it is tensile force. Because we get a positive value, it means this assumption that we had assumed this FAB is tensile, right? Because away from joint is tensile, and since we get a positive value of FAB after solving equations, it means our assumption was right, and that's our answer. Okay, so 7 kilonewton tensile, right? So AB, force in AB is 7 kilonewton tensile. So our calculations are right. Okay, so this way we will move on to the another joint. Okay, let me first erase this joint, we will then apply to, and we'll jump to another joint later on. Okay, now we found the forces in AE and AB, right? We found AB to be 7 and AE to be negative 9.9, right? Negative means compression. Now let us apply the equations of equilibrium at joint D. Okay, now this is joint D here. Let me draw. Now I'm assuming force in this is DE member and this is CD member. I'm assuming all the forces are tensile. Okay, this is force in DE and this is force in CD, and this angle is theta, and remember theta is 45, right? This is theta. Okay, now when we draw the axes here, now let me first change the color here. Let me change the color. Now when I draw the axes here, this is going to be y, this is going to be x. Okay, this equation, so let us apply these equations. But again we have this problem, FDE is neither in the x direction nor in the what, y direction, right? So we have to resolve FDE into cosine component. So let's say this is FDE cosine of theta, and we have to resolve FDE into a y component. Okay, so let us say this is FDE sine function sine of theta, right? So Now let's apply these equations one by one. Now also remember we have this 8 kilonewton at D upwards. Okay, I have to show it also. Okay, 8 kilonewton, because in the free body diagram of the joints or any free body diagram we show all the forces, the support reactions, the external loads, whatever, we show all the forces. Okay, so now let's apply the equations of equilibrium. Now we have this 8 kilonewton in the y direction, so we will first apply this equation. Okay, summation of f of y equal to 0, assuming upward forces are positive. Okay, now 8 kilonewton is upward, so this is 8 kilonewton. FDE cosine theta is upwards, so this is also positive, so all of it is 0. Okay, because these are the only forces in the y direction. So from here I am going to get the value of FDE to be negative 8 kilonewton divided by sine function of theta is 45 degrees, right? So let us find it using calculator. Minus 8 divided by sine of 45, it is minus 8 square root of 2, right? So it is approximately uh, negative 11.3. It means it is 11.3 but compression. Okay, 11.3 but C. Negative means our assumption that this FDE, it was tensile, this is the assumption is wrong, and the force is actually compression. Okay, and we show a compressive force in a member by drawing this arrow towards the joint. Okay, so FDE is 11.3 kilonewton C. Okay, so let me see the options. Force in DE is here 11.3. Okay, so our calculation is right. Okay, now so let me write it here. FDE is numerically equal to 11.3 kilonewton. Okay, this is 11.3. Okay, so let me erase this equation first. Now let us apply this equation at the joint. Summation of forces in the x direction is 0. This let us see the forces in the x direction. This FCD is in the x, right, the horizontal direction, but it is towards left, so this is negative here, negative FCD. Now this FD cosine of theta, it is also towards left, so this is also negative FDE. Do we have another force in x direction? No, so it is 0. Okay, now I know the value of FD is negative 11.3. Okay, so this negative and negative will cancel out, it is going to be positive 11.3 here, and from here we will get the value of FCD. It is 11.3 cosine of 45 degrees. Okay, so let me use a calculator. 11.3 multiplied by cosine of 45, so it is approximately equal to 8 kilonewton. Okay, because it is a positive value and the positive means it is in tension. Okay, so force in CD is where it is, yes, right, it is 8, so all the calculations are right. Okay, so this way we jump to another joint, okay, so let me erase this joint, then we will apply method of joints, the equations of equilibrium to the another joint. Okay, whatever we find easy. So let me erase this first. Okay, now we applied method of joints at this way, and we also get this and this, the member, the force in these two members, right? Now which one is easy? We can apply at any joint. We have to see that it is a little bit simple. Now let us apply equations of equilibrium at joint C. Okay, so let me draw the free body diagram of joint C. This is 9 kilonewton downwards. Let us say this is joint C. We have this force in this unknown force. Let us assume it to be, let me first draw the coordinate axis. Okay, this is x-axis and this is y-axis. Okay, so we have this CE connected to CE. Okay, so I'm assuming the forces in CE is tensile. Okay, like this force in CE. Okay, and the angle it is making with the x-axis is alpha. Okay, this angle is alpha. And what is the value of alpha? This is 71.6, right? 71.6 degrees, right? This is the value of alpha. So we also have CB member here, right? Let me erase this, we don't need this anymore. So we have this CB member, okay. We're also going to assume it is tensile. Tensile means away from the joint. This is force in BC, okay. So did we write all the member forces at joint C? Yes. We have also considered the force 9 kilonewton, and this also, okay. So where I think the free body diagram of joint C is complete, okay. So let's apply the equations now. Which equation we apply? Which we apply first, summation f of x or summation f of y? Which we are going to apply first? Yes, we are going to apply this equation. Why? Because in the y direction we have something given, right? The value is known in the y direction, so that's why we are going to first apply this equation, okay. So this will save our time. We can also apply this equation, but it will, we have to solve these equations, the substitute method. So let us apply this, assuming upward forces are positive. Again, this FCE, it is the problem, right? This is neither in the y nor in the x, so this is FCE sine of alpha, and this component here, it is FCE cosine of alpha, right? Let me just write alpha because I know value of alpha is this 71.6. Okay, now we have resolved this FCE force, so we are good to apply this equation, okay. So FCE sine of alpha, it is upwards, so it is positive. FCE sine of alpha is how much? 71.6 degrees. Then we have 9 kilonewton, it is downwards, so it is negative 9 kilonewton, right? Do we have another force in the y direction? I think no, so I will equate it to 0. So from here FCE is going to be, it is going to be like this, right? So from here FCE is going to be 9 divided by sine of 71.6 degrees, right? So this is going to be the value of FCE. So let me use a calculator. 9 divided by sine of 71.6, it is going to be approximately 9.5, okay. 9.5 kilonewton, okay. So we get a positive value of 9.5. It means that the force in the C member is actually tensile. Why? Because we get a positive value, right? So where is C? Is this 9.5? It is actually 9.5 kilonewton, T for tension, okay. So our calculations are right. So let's apply this equation, summation of f of x. So first let me erase this. Summation of forces in the x direction is 0, assuming forces towards right, they are positive. Now let us sum up forces in the on the x-axis, right? Now FBC is in on the x-axis, but it is towards left, so this is negative FBC. Similarly, this FC cosine of alpha is towards left, so this is also negative. Cosine of alpha is 71.6 degrees, right? Now these are all the forces in the x, so we equate it to 0. Now force in CE is how much? It is 9.5, right? We already found it before, 9.5. So this is going to be 9.5 kilonewton, right? So when we rearrange this equation, when I throw FBC to the right, we are going to get FBC to be what? FBC is equal to negative 9.5 kilonewton multiplied by cosine of 71.6 degrees, right? So let me use the calculator. Negative 9.5 multiplied by cosine of 71.6, it is negative 3. Negative 3, right? So force in BC is negative 3 kilonewton. It means it is 3 kilonewton but compression, right? C for compression. So where is BC? Yes, it is. Force in BC is 5 kilonewton No, I think I did some mistake. Where is the mistake? Let me calculate it again. 9.5 multiplied by cosine of 71.6. I think the my answer is correct. I don't know. I think my answer is correct because I could not find any mistake in the calculations. Let's assume for a moment that this force in BC it is actually 3 kilonewton compression. Okay, let's assume it for a while, and please check if I am right or these options are right. Okay, because I could not find any mistake. Okay, so let's move on to another joint. So let me erase this first. Okay, now we found the value in this BC and also in CE. Okay, now what do we have? We need the force in this member now, BE, right? So we can apply the equations of equilibrium at B. I mean to say we can consider joint B to find the force in BE, or we can also consider joint E. Okay, now I think in B we have only 1, 2 and 3 members, so B is going to be easy because at E there are going to be 1, 2, 3 and 4. Okay, so the better is to consider B joint. Okay, so let's consider joint B. At B we have 6 kilonewton downwards, 6 kilonewton downwards. Then we have this BC force, right? The value of BC is negative 3 kilonewton, right? As we found here, negative 3. And then we have AB. What is the value of AB? We already found it is 7 kilonewton, right? 7 kilonewton. And then we have this force in BE, which is unknown, right? I am assuming force in this BE is tensile, force in BE, and this angle is alpha. Okay, and we know the value of alpha is 71.6. okay, so let me draw the these axes first. This is our x-axis and this is our y-axis. Okay, so this is x-axis, this is y-axis. Okay, so this FBE, again it is neither in x direction nor y, so again we need to resolve FBE into x component and y component. Okay, so this is the x component, FBE cosine of alpha. This is y component, FBE sine of alpha. Okay, so this is the free body diagram of this. Okay, this joint B, right? This is joint B. Did we miss anything? I think we did not miss anything, so let us apply these equations again. This 6 kilonewton is in y, so we will apply this equation first. Okay, summation of forces in the y direction is 0, assuming upward forces are positive, right? So this is now sum of all the forces on the y-axis. So this FB sine of alpha is upwards in the on the y-axis, right? So this is positive, FBE sine of alpha. Now this 6 kilonewton is downwards, negative 6 kilonewton. Do we have another force on the y-axis? No, so sum of them is 0. From here we are going to get the value of FBE. It is going to be 6 kilonewton divided by sine of alpha. Alpha is how much? 71.6 degree, right? As you can see here, 71.6 degree. So let's apply the use the calculator. 6 divided by sine of 71.6. Okay, I got the value 6.32. Okay, I don't know if it is right or wrong. 6.32, it is positive, it means it is tensile force, right? 6.32. Where is B? Force in BE is here. Yes, 6.32. Okay, I have rounded it off to 6.3. Okay, so we got all the values. Okay, you can see we got the value of AB, we got the value of BC, we got the value of CD, we also get the value of DE, AE, BC. Okay, now right now we will stop the method of joints. Why? Because we found forces in all the members. So for what we are going to apply method of joints? Because we found all the forces, so that's it. Okay, We have found all the member forces in this truss using method of joints. I hope you enjoyed with me. Okay, and if you have any doubts, please comment, and please consider give, giving me a thumbs up if you enjoy this video. If you actually learn from my video, please give me a like. Otherwise, it's your choice. So that's it for today. See you in the next class. Thank you.